Good morning, students. So let's start chemistry chapter number 2, the part which we have left before the exams, that is mixture. But before that, let's revise what we have learned in our previous class. So we have learned about matter. So what is matter? Matter is anything which has mass and it occupies space. Okay, matter has mass and it occupies space. Okay, so non-living matter is categorized into two: pure substances and impure substances or mixtures. So pure substances are those which are composed of a similar type of molecules or atoms, you can say, or have a uniform composition throughout. Further, we have learnt in our previous classes that pure substances is categorized into elements and compounds. So element is a pure substance that cannot be separated into simpler substances by any physical or chemical, that means ordinary means. Why? Because these elements are made up of one type of atoms, one or single type of atoms. Okay, suppose example what we can take hydrogen, okay, which exists as a molecule. I have told you the difference between the atoms and the molecules. So here what happens, two atoms of hydrogen makes a hydrogen molecule. So the atoms are similar, okay, so they have similar structure, similar everything. So this is an example of an element. Similarly, gold, silver, all those are example of elements. Now see the compounds. See here, what's there? Yes, water in a bottle. So water which we commonly drink is a compound. Okay, so what is the formula of water? Absolutely right, H2O. Now if we'll further break this H2O, what we'll see? H. Okay, so let's write O in another color. That means a water molecule has two atoms of hydrogen. Okay, this is the first, this is the second, and one atom of oxygen. So this has a fixed ratio of 2:1. Two atoms of hydrogen combines with one atom of oxygen. Okay, similarly we exhale the carbon dioxide gas, so it also has one atom of carbon and two atoms of oxygen. Carbon, di means two, okay, dioxide. So all these are examples of compound. I hope this is clear. Now today in this class we'll learn about mixtures. What are mixtures? What are the characteristics of mixtures? What are the different types and how we are going to separate the different types of mixtures? Now let's see about mixtures. So mixtures are, impure substances, or you can say they are not pure substances. They don't have a similar composition throughout. They may have two pure substances combined in any ratio. Okay, so the pure substances may be an element or compound. Okay, so that pure substances may be two elements or two compounds, or an element or a compound, okay, like that. So if they are mixed together in any proportion, so they are mixtures. So whatever we use and see every day, are many things which we see are examples of mixture, like soil. You know, soil is a mixture of sand, clay, pebbles. Okay, then rock is a mixture of different minerals. The air which you breathe is a mixture of many gases. Okay, so there may be different types of mixtures okay, around us. Okay, so when you come from the hot sun, what your mama gives? Generally, you drink rasna, or maybe you will drink some glucose or glucose water, or maybe lemonade that is made up of lime juice and sugar and little bit of salt and water. So all these are mixtures. Okay, so every day we come across different kinds of mixtures. Now let's see and define the mixtures. So mixture, when two or more substances, that may be an element or a compound, so they combine together physically and in any proportion, that is a mixture. Physically means they can be separated by simple methods like sugar and water. Okay, so here what happens when we make a mixture of sugar and water, then what happens? The water tastes sweet. That is the characteristics of sugar. The characteristic of sugar is sweet. Okay, and water is liquid. So none of them, when we mix sugar and water, sugar with water, then what happens? Neither of them lose their identity. So the components of a mixture retain their identity. Okay. Now let's see the classifications of mixtures or the type of mixtures. Okay. So mixtures are of two types: homogeneous mixture and heterogeneous mixture. A mixture of the sugar and water is said to be a homogeneous mixture. Why? Because even the last drop of sugar water will taste you sweet, and you cannot see the particles of the sugar inside the water after mixing. So in a homogeneous mixture, the components are uniformly distributed. That means, see the name, homo means same. So a mixture in which, or a mixture which has uniform composition throughout and has same properties, like the sugar and water when they are mixed, or salt and water when they are mixed, then what happens? Even the last drop of the water will taste sweet or salty. Okay, so such mixtures are called as homogeneous mixtures. Okay, so you can't see the particles of a homogeneous mixture. Okay, so that means components of a homogeneous mixture, okay, are uniformly distributed. That means equally distributed in all parts, and you cannot see any clear boundary of separation between the particles of a mixture. Now let me make this clear with the help of a very simple example. Here now I have an empty glass, and here is some water to be added in this empty glass. Okay, so water is a liquid. Now what I'll do, I'll just mix this green color syrup, okay, so in the glass, and we'll completely mix it. So let's mix it up with the help of a pen. So after we mix it up, if you will see the glass, there is no separation of the or there is no layer of distinction between the green color syrup and the water. Okay, that means it is completely mixed. Okay, so such mixtures are homogeneous mixture. Now let's see another example. Again I'm adding the same water, okay, in a glass. Then let's add some oil. to this class and see what happens. Shall we? So here you can see, if I'll add oil, see here, if you will look from the sides of the glass, okay, or you can see from the above, there is a distinct layer of oil and the water. And why is this? Because oil doesn't mix with water. So there is complete boundary you can see between the two, or you can see there is a distinct layer. So such mixtures are called heterogeneous mixtures. So they won't have any uniform composition throughout. Okay, so see here, if you can see, there is a distinct layer. Okay, so distinct boundary is there. Now if we'll mix this paddy seeds with, you can say, some sugar, so such mixture will also be a heterogeneous mixture. Okay, so if I'll pick some, so suppose what I picked, so there is some more sugar and one paddy seeds, so this won't have a uniform composition throughout. So a mixture which has non-uniform composition throughout its mass is a heterogeneous mixture. So I hope you have understood the difference between the two. So homo means same and hetero means different. Okay, so a mixture which has uniform composition throughout and have same properties, like this sugar syrup, that will be a homogeneous mixture, and the mixture which has non-uniform composition like this will be the example of a heterogeneous mixture. Okay, now let's see things are there which you need to do as your classwork. First one is, mixtures are classified as dash and dash mixtures. Okay, as dash and dash mixtures. Second question is, mixtures are dash substances. There is a choice given, either they are pure or impure. Third question, you need to write what are mixtures and you need to explain your definition with the help of an example. Fourth question is, you need to define homogeneous mixture and heterogeneous mixture, and you need to give examples of each. Okay, so this you keep in mind. Okay, okay, so give one examples you can write, not more than that. Okay, so these are your work you need to do today as your class work. Tomorrow we'll discuss about the characteristics of mixtures, homogeneous mixtures and heterogeneous mixtures, and the difference between a compound and a mixture.